Okay. Okay, DC circuit analysis. I'm going to pass out a lab. I'm going to work on this a couple of days this week. Yeah.
Absolutely, brother.
I'm missing a couple of people. No. No, this is a new lab. So we got Corey, we don't have Benjamin. And we have, where's Dakota? I don't have Dakota. We have Jesse. We have Christopher. Frederick.
Yes, sir.
What's that?
I've only had one day out on semester.
Okay. Robert's over there. Gary. Donald. Yeah, come up. Go ahead and show me your homework. Corey, can start. And then we got Jesse. Do you have any homework to show? Christopher, do you have any to show? Frederick, do you have any to show homework?
I'm not even sure what it was that Charles did.
I had a lot of assignments online.
There's the notes.
Take the notes.
Through, and then I got the examples in here. I didn't make it all the way through chapter 9.
Okay. Thanks. Robert, do you have any homework to show? This class?
It was on last time.
Like any of your notes you took on semiconductors, any of the lab work you did in your lab notebook, any of the homework you did online?
I haven't finished rewriting all of them, but here's what I have for semiconductors so far.
Okay, good, good, yeah.
Still about 15 more pages.
Showing me something is better than showing me nothing, so just anything you've got that you think could be, your work that you're trying to show that you've done. It should be on semiconductors or either on the last coils and transformer lab, either one of those. Don, do you have anything? Okay, semiconductor symbols. Okay. Yeah, good. That's good. Yeah, since we're on semiconductors right now, what I'd like to see in your notebook is drawing the symbols, the schematic symbols.
Right.
Also, for you to have drawn the coils and transformers that we did last week would be good to show me. Any of the homework assignments that we've done up to this point, especially the most recent ones. And then Clarence. Okay, good. I keep a track of who does a lot of homework in your grade, and because I like to see usually pretty much 1-to-1 match between the amount of work you do at home and on your own time and your grade. There's a very, very high correlation. Usually the people that make F's and D's and things like that, they're practicing during test time. Practicing is for home when you do your homework. It's not, okay, here's a test, I'm going to practice all this stuff I've learned. No, that doesn't work that well. Practice at home. Practice so that I can give you feedback, show me your information, ask questions. That's the way it's supposed to work. That's the way that is the most efficient and will guarantee your success, or almost guarantee your success in this class. So if we look at the lab we're going to be working on this week, we're going to need some transistors, and I'll show you guys how to find this information. And I'm going to show you guys a demo. But go ahead and make sure that when you look at this, look at the instructions. It says record all information in your lab notebooks, including schematics, calculations, drawings, graphs. Number all the data with the same paragraph numbering as items listed below. So I would put like Semiconductors Lab and then put 1, 2, 3. Read the entire lab before beginning. The lab is that you want to, given the circuits in the lab, they're numbered on page 104, 105. You got these little schematic diagrams. Okay? And I want you guys to pick one of these. You got a moisture meter, moisture activated relay. You've got a metronome, light flasher, siren, high voltage power supply, or a burglar alarm. Now we don't really have this type of alarm. We could use like maybe a piezoelectric or something. This one would be, you guys could do this one too. I'd have to go pull a transformer out in the back and we'd have to break it up. And this one would be kind of dangerous because you have this high voltage, so I don't know. Be careful if you do this one. Some of the safer ones to do would be like a siren. That'd be kind of cool. You have a speaker. It's just one transistor, a resistor capacitor, metronome, light flasher, and moisture activated relay. So these first 5 or 6 would probably be better. Now I'm going to actually build this light flasher and demo it for you guys, but you guys can go ahead and get started, but make sure there's a lab time portion and then there's a for home portion. The homework part of it is use your lab time to build things and troubleshoot circuits. Use your home time to draw the schematic, do any sort of writing that you can do. You can do that anywhere. So also, once we get this built, just a simple Microsoft Word report of name of the project you chose, description, parts list with reference, designators, part numbers, quantity, name of component, summary of how the project worked, summary and conclusions, upload the files to Moodle, extra points for showing me, printing it out. I like to see a printout. It would be better to see a printout and show me on the day that it's due. It's not going to be due, it's going to be due Friday is when we're going to have it due. And for the data sheet, I put the data sheet in the back, just a one-page data sheet. But if you want more data sheets, we have this transistor data sheet kit that I made. And you can go to the 2N2222 and you can find all the information for that data sheet. Part of the hardest part about it is figuring out the orientation of the part and how does it go in there. And you can see here on the screen that if you look at the transistor from the flat side of it, it's from left to right, emitter base collector. And those are marked EBC on the schematic diagram. EBC. Makes it a little bit easier for you. You don't have to memorize the symbol, but it's trying to get you to in a real schematic, it's probably not going to be marked EBC. You're going to have to just know that that's EBC. But in this, it's showing you to try to get you up to speed on, since this is like a beginner level. But at an intermediate or advanced level, the EBC would not be marked. You'd have to know how to go get the data sheet. So number 5 is to draw all these components in your lab notebook. You can do that at home. Don't waste time in the lab doing that because you can do that at home. And then under each component, write one sentence of basically what that component does. This lab is kind of the culmination of everything you've learned up to this point and what we would expect a very, very basic level of technician to be able to do when they graduate. At the very lowest level. At the very lowest level, a technician needs to be able to build a schematic from a schematic diagram. They need to be able to troubleshoot that. They need to be able to record data. They need to be able to use test equipment. They need to be able to record data, to the point to where they can write a report or put together a composition of a work so that they can show it to their peers or send it as a lab report or conclusion report. You have to be able to use Microsoft Word and Office. That's expected in industry, that you guys know how to use those tools. So everything in this lab is really the culmination of the entire program, but just at a really low level. And a lot of this stuff is going to be like, this is the first time I've ever done it, but it's okay. Because it's really, this tells you the need. This tells you if you don't know how to do something, it's okay. Maybe I haven't taught you everything, but it shows you what you need to know, and then you can ask the questions. So it's just a baseline starting point of us getting into knowing what we need to know by the time we graduate. So you guys can go ahead and get a bench, and I'll show you really quickly where you can grab these components from. Yeah, and here's your books. If I was you guys, everyone grab one of these transistor books. Yeah, we're not gonna tear this down. We're gonna try to keep these
Together?
for the whole week.
When will we get our own kits, or will we?
So oh, did everyone get an email about your software?
No. What's that about?
Everyone got your.
I mean, it's safe to download. I didn't know what it was about.
Yeah, go ahead and download it. Download your. If you got a software to download, then go ahead and download. But we're gonna go through an exhaustive training on that software. But just making sure everybody got it. Everyone come over here really quick. I'll show you guys how to find your components. So we've learned coils, caps, transformers, magnetics, all the way up to transformers and semiconductors. Most of these schematic diagrams have at least one transistor on it. All of them, I think, have a 2222 transistor. Now that transistor is going to be located down here, and this is where the transistors on it. This says switches. This says diodes. Okay. So the one that says transistor, you look through here and you just find the part number that says 2222. 2222. It says PN2222. Okay, they're going to have different names, but it says on here front and back. So you can just pull out the door on the front if you are 2222. You can look at the component, and it should have a 2222 something on it. And the back is 2907. And some of the devices have a 2907. Now those are 2N2222 is NPN. And the 2907 is the PNP. Okay. As far as the number one problem most people have with assembling something off of the schematic is getting everything oriented properly and connected. If you see in the top left of your schematic, you see the little transistor symbol. You see it. It's trying to show you the flat part of this. There's a flat part and there's a round part. If you look at the flat part, it tells you EBC from left to right. That tells you that this is EBC from left to right. So you know how to connect it in your circuit. Now what we're going to not do is we're not going to start bending these pins. What we're going to do is come up to the board. Everybody can see this. All you got to do is take one of the ends and put it kind of in the board. Put a little bit of pressure on it, and you can spread it out. Walk it over. So you don't, just the minimum amount of spacing. You don't have to jerk those leads and put one over here, one over there, and one over there. Just make it straddle the three closest ones. Okay? Make it straddle the three closest ones when you pull it out. The only thing you need to do is get access to the pin. Okay? And then one of these has a diode, 1N914. So you go to the diode doors over here. You just look around until you see 1N914. Now, part of this being a technician is learning how to find components. So it's great if I can come find a component for you, but it's even better if you guys can find it on your own. Lamps are, I think we do These are switches. All these are here are switches. You have a switch. Everything up here is capacitors. A lot of these probably have like polarized capacitors. Polarized capacitors are right over here in their mark. 22 microfarads right here. A lot of them have 22, so they're right here. They're all in order. 1 microfarad, 2 microfarad, 4.7 microfarad, 5. So they're in order from lowest to the highest. Usually from top left, lowest, go to the right, like that. To the highest value. The highest value big ones are on the bottom here. The small, teeny, tiny ones are up here on the top right. But that's the numbering from left to right, top to bottom. And yeah, if you do one that has a buzzer, you know we got some of the buzzers right here. We got one that has an alarm, the buzzer. We got one that has a speaker. You can come to me, we have speakers, like here's a speaker, here's a speaker. You know what? I got more speakers. We got some speakers in those right here. Meters, like this first one has a little galvanometer. We got a bunch of those. I think there's right here, galvanometers. Potentiometers are actually down here on the very bottom. They're on order. Okay? And they're marked front and back. Now what you have to do is just look on them and find that 50K, 100K, see right there, 100K, 50K, back and front. So they're marked with 100K, 50K, right there. 50K, 100K. And so hopefully, I'm not really wanting everyone to build the same thing. I'm hoping that everyone's going to build, not everyone's going to build something good. Don't try to get together and all build the same thing. Try to pick something that's interesting to you and build it, even if it's not the same as someone else. Then we'll demo it to everyone and see how it works. Bookstore, yeah. Related bookstore. Oh, it's okay.